very, very excited to be here. And what we want to talk to you all about today is a comparison of systems. So as Stephanie and I talk about these products, we typically don't talk about the product by itself. We talk about it within the system. And a comparison of systems is very important because, as I mentioned, I farm in Central Illinois, and this is a photo I shot Saturday, and it's of two fields, and they're directly across the road from one another. Same soil type. The nitrogen programs from how much total nitrogen was applied are very, very similar, and the planting date is the same day. But it's obvious the management of these fields is quite different. And as you hear Greg say, we never want corn to have a bad day. This corn is starting to have some bad days, and this corn is not. So that's what we want to talk about. We want to talk about a systems approach that really focuses on high intensity. And as I think about that, I always focus on what has happened to me from my own farming experience that helps tell that story. And I'll go back to 2012 where we had a historic drought, and I know many of you did too. For me, that drought was actually worse than the drought of 1988. We had less rainfall in 2012 than we did in 88. As a matter of fact, I had a couple fields that never received a drop of rain after we planted. So our yield levels were darn near as bad as 1988. The only thing that kept it up was the great work that the seed industry's done on improving genetics for drought tolerance, trait technology to protect it, but at the same time, my yield on the overall farm was under 100 bushel. So that is suffering through a bad crop. So as I think about high intensity management in my crop plan, I had to ask myself a question, and I'll ask you. Have you ever said, do I want to throw good money at a bad situation from a farming perspective? I asked myself that question, and the answer was, nope, I'm not going to do it. I chose to reduce my inputs and back away from the management plan that I had. And the problem with that was I missed a heck of a good opportunity because commodity prices were at record highs. We started harvest on August 10th, and I was taking it across the scales and selling it for over $8 a bushel. It's proven, and through all my years in the seed industry, I've seen the data that shows that crops under stress respond at a higher percentage yield increase than those that aren't under stress, like this, to fungicide, notwithstanding disease. I'm not saying more bushels, but a higher percentage. So if I could take an 80 bushel crop and all of a sudden add 8 bushel to it, think about that, a return on investment. It's very, very attractive. So I fast forward to 2013. What happened? Commodity price dropped significantly, 45% in my area of Central Illinois. So I had to ask myself the question, am I going to throw good money at a bad situation? And the fact of the matter was it really wasn't a bad situation because we had growing conditions almost as good as we have this year. So I chose not to reduce inputs. I stuck with my plan. Now, I didn't just go out and apply inputs blindly. I looked at each field and what does that field need, but I was able to take advantage of the opportunity that the environment would give us and thought about how do I capture the potential out there. We were able to take our whole farm average up significantly over what had ever occurred in the past. So why am I telling this story? I'm telling it because now more than ever, I think high intensity system management is needed. We are now sitting with a 3 in front of the corn number. In some areas where the basis is huge because you can't get rail cars, you may have a 2. We wish we had that commodity price. But since we don't, what are we going to do? What we have to do is manage at a point where we get the most out of every input we put on. And I'm going to talk about nitrogen today. As I mentioned, Stephanie and I don't talk about these products in a silo. We talk about them as a system because each of the products we have in Sense, Decide, Apply are strong. But when you combine them together, they become a force multiplier. They help us achieve that goal of capturing the potential. And for me on my farm, it all begins right here with the Decide piece. You've all been through 360 Commander, correct? Seen Daryl and Tim's, yes? I love that tool because it takes global modeling, it takes weather data real time, so I understand where my soil water profile is. I understand how much holding capacity I have, how much I have left. I understand what the historical weather has been, so I can look at what projection I have moving forward. But the beauty of it is I can add, from that science standpoint, I can add the art of farming, because farming is an art. So I can put in my P's, my K's, my CECs, my organic matters, my unique yield management zones, and now I'm building that very, very close to me because my farm's unique, just like your farm's unique. They're different. We use different management styles. I can take my nitrogen management and plug it right into that tool and see what's going to happen. So for me, that's important. I can then take soil scan data and understand where are my nitrates at, and that's pretty important too, because this spring, Greg received very little rainfall up here. He was getting just enough to keep his corn crop really cranking, where you saw a picture of one of my farms where I was receiving more than enough, so my nitrate levels in the top 12 and the 12 to 24 look much different than Greg's. Therefore, we have to manage that crop much differently. So I've got Decide, and we're inundated with data. So I have all my yield map data. I've got all my fertility data. I've got hybrid comparison data. I've got fungicide data. I've got data coming into me. Everybody says, here's some more data. What am I going to do with it? Data without a way to apply it isn't really relevant to our farms. If I have data, I need to be able to take an action with that data, and that's what the apply side of our system approach is about. And that's what Stephanie and I are going to talk about. So for me, when we think about nitrogen, the first thing we have to understand is, when does the plant really need it? Greg showed a photo of a gentleman out side dressing at V4. And you can see here at V4, the plant has taken up very little of its overall needs. As we think about where the crop really starts to use nitrogen, it's coming out here right at this VT. And I look up here and I'm saying, wow, 55% of the nitrogen that crop's going to need to finish out, to fill that grain, to fulfill that total potential is going to be needed after VT. So how can I possibly go out and really understand where that nitrogen need is going to be at V4? So from a systems approach, what we want to do is enable you to push your application out later, where you understand what Mother Nature is giving you in regard to rainfall. So I continue to get rainfall. If I'd have put it on at V4 and I received another 6 inches of rain, now my nitrates look a lot different. And the availability here, when I need to fill that ear, is going to be totally different. So having that opportunity to push it out is pretty critical. This is a way to a great example of showing that in regard to yield. This is a couple sets of photos that Stephanie gave me, and I love them because they really illustrate this. This is the same field with two different nitrogen programs applied to it. Same amount of nitrogen, just different timings. The ears on the left here are with a late-in application. This did not have the late-in application. They're both 16 around, but you can see that the actual girth is much different. But let's just pretend for a second that the kernel depth is the same. This ear has pulled itself back to 32 in length. That's a natural response to lack of nitrogen or lack of water. It's going to pull back. It's got to preserve the butt of the ear up. Where we had the late nitrogen application, we've got a 38 length. So what does that mean? What's the difference there? If I have 16 by 32, and I have a 34,000 ear count, and I'm assuming it's going to take 90,000 kernels to build a bushel of corn, I've got 197 bushel corn. That's not too bad. Until you consider where I've held 38 and I use that same formula, now I have 230 bushel corn. And let's take it a step further. As we look at these kernels, where there's not a late nitrogen application compared to where there is, I mean the kernel depth is significantly better with the late nitrogen application, and with depth goes grain test weight. So as I've increased that depth and that test weight, what if the divisor on the bottom of that yield equation isn't 90,000, but only 80,000 kernels to build a bushel of corn? I've now taken that yield up to 253 bushel. And this is not a spreadsheet exercise that I'm doing here. This is real. This is happening today, and that's the effects of high-intensity nitrogen management. We talk about we never want corn to have a bad day, but here's the fact of the matter. We don't work in a pristine factory. Our factory's right here. It's right out there, and you see what's happening right now. We have no control, whether it's going to rain, whether it's not going to rain, whether it's going to be too hot, whether it's going to be too dry. So the uncontrollable, how do we give people control over what was once thought uncontrollable? Here's a field. This is from central Illinois, and if you're up in North Dakota or Minnesota, you know how too much moisture looks like. This field was inundated with rainfall shortly after planting, and you can see, especially in the depression areas, how much nitrogen loss you have. This corn is having a really bad day, and it's got a long way to go. It's not even the VT yet. It's probably at about V8 or V9. Dr. Scharf at the University of Missouri has done a lot of data on rescue treatments of corn with nitrogen. So when corn does have a bad day, how do we react to it? And his data is pretty fascinating, actually. He's showing that in high-stress environments, he's adding 57 bushel per acre. In medium stress, he's adding 41 bushel per acre. And even in areas where there's low stress, a late application of nitrogen is adding 14 bushel. So late nitrogen does pay. How do we do it? So I said data and information without action really isn't acceptable in the 360 world. So Y-drop is how we're going to do that. And Y-drop does two things uniquely very, very well. And it's different than anything else you'll see in the marketplace. Number one, it places the nitrogen in a very targeted way right next to the stalk. And secondly, it widens that window out, so now I can push away from a V4 side dress closer to a V10 side dress. You've seen this picture, Greg showed it. This is where the application of the nitrogen or whatever cocktail that you're putting down from a nutrient standpoint goes. And that's important because what we're seeing right now is Mother Nature's gift, and the corn plant knows how to use it. It's stem water. The corn plant is a greedy plant. It stretches those leaves out, and it grabs every sunlight ray it can grab, and it grabs every drop of water it can grab. This shot here is after 15 1/100ths of an inch of rain, and the shot was taken 13 hours after that occurred. That is significant because that is real moisture. And as we think about that incorporation of the nitrogen, I want you all to go back to the pit that Greg spoke in front of and think about those root masses. What did they look like? The root mass of that corn plant starts at that stalk, and as the crowns start to develop, it builds out, and it builds out, and it goes down like this. And it was vivid because you could see it. And 80% of that 3,000 miles of highway transportation Greg's talking about is going to lie within that 18 inches. And that's critical because as we push nitrogen down, we have the ability to take every single pound and bring it back up and stick it into the corn plant. So now that's critical for three reasons. Number one, I'm going to be able to get more bushels out of a pound of nitrogen. So economically, it's great for me because I'm lowering inputs. Secondly, I'm getting more bushels out because I'm starting to capture that potential. And thirdly, Greg talked about this, Toledo, Ohio. The issues going on there, I'm going to guarantee you they're going to point their finger at agriculture, and all of a sudden we're going to have a whole bunch of people wanting to help us from a regulatory standpoint. We need to take control of our own destiny and manage our nitrogen, our fertility, before somebody else helps us. The window is very wide with the Y-drop system. We're able to go out from a V6 standpoint all the way up to VT, but the question I ask once again is why do we want to go out at V6 when this product gives us the ability to wait until V8? That's about V12, and that's that sprayer right there. That's not a high clearance sprayer. So we're able to really open that window up and give us opportunity to stretch out that window of application. On my own farm, I've got a John Deere 4730. It's not on a lift kit, so it's a clearance similar to this. And we began at about V10, so it was about this high. And we applied and got a rain right after the first day. It's beautiful. Really incorporated nicely. And then we went back out after it dried up, and we applied for a couple days and got another rain. And we finished up at, it was Father's Day weekend, and my corn was V12, so it's about this tall. And I'm sitting here going, wow, I mean, what an opportunity, because now I've had all this extra rain, so I can recalculate what my prescription looks like, because it's going to look different than it did 10 days earlier, because I've gotten all this rainfall. All of a sudden, my subsoil is full. It's fully charged, so I'm looking at my yield potential, and it's going up. And it's at a level I've never seen. But I'm looking at my projected yield, and it's actually on a decline. And that's because I'm leaching nitrogen out of where the root system can get to it. So now I have that choice to make. What am I going to do? I'm going to go ahead and I'm going to apply that variable rate prescription that I'm writing on the day that I'm going out and doing the application. And that is an example of taking control of something that I think once was thought uncontrollable. And it was really cool. It's one of the coolest things I've ever done since I started farming, was do that application, because you're in that sprayer, you can't even see the front tires. I'm in 20-inch rows. I've got trams, so I've got a little leeway, but it's the sense of almost flying across this beautiful green cloud and spraying and knowing that you're doing everything you can with all the information you have right now to get the most out of every single acre. For me, it's about getting better on every single acre. And I think if you get better on every single acre, it gives you the ability to get bigger, if that's what you want to do. This is a shot of that same field that I showed you with the Missouri data. I think in the past, once again, this grower would have said, well, you know I need a late nitrogen application, but how am I going to do it? I guess I could try to fly some stuff on, and we know that effectiveness can vary. We were able to write them a variable rate prescription that understood what's going on in these areas of stress, but at the same time understood the higher level, or the higher areas where he still had tremendous potential. And he was able to go out and apply that solution. So I've talked a ton about corn. This is also a great tool for soybeans. You know, when I first came here to 360, Greg would jokingly say, soybeans are a weed. Now he's kidding, and now he says they're a secondary crop. There's 80 million acres of that secondary crop. So why don't we want to intensely manage soybeans the same way we manage corn? Soybeans have a tremendous yield potential, and now we have a new tool in our toolbox to go out and do some late season applications of nitrogen, potassium, all types of things. This is actually a research farm. This is one of mine where we're doing different protocols of fertility feeding. On this one, this is a nitrogen potassium feeding. And you can see we're running through this field, and even in the tram lines, we're not really doing much damage to that crop. And the wide drops we're able to run right down through here and not pendulum back and forth. 20-inch rows. So we're doing a lot of research with nitrogen, potassium, phosphorus, micros, all kinds of things with wide drop in both corn and in soybeans. And one thing that's exciting, is there anybody here that's in one of the hot zones with corn rootworm, where your populations are just really, really high and it's starting to overcome traits? Anybody? Okay, a couple of you. We're doing some research around liquid insecticide coming through this system, applied right at that base at different stages, and we're seeing some really nice results. So it gives you guys another tool to work with as you manage that type of rootworm population.